Hello, good morning, my dear thinkers, my dear friends. This is your science friend Srinivas from scientificstudents.com. Today I am so happy to share one of my tinkering. This is energy meter for all my gadgets. So today I start with my water pump. We have a sump here. You see, this is a sump. In my home, we have a sump here. So, whenever we wanted to pump up the water from sump to my overhead tank, we use this motor. Okay. Now, I wanted to know whether this motor is perfectly working or not. Do I need to go for a maintenance in this motor? Is it taking the required current or it is pulling more current? Is it consuming more energy than the rated or whatever? I wanted to check it out. So, here is the energy meter. You see, my dear friends, so here in this energy meter, you can see, all the voltage, current, watts, watt-hour, and frequency of the supply, and also power factor, everything you can see. Now the current is 0 because the motor is not switched on. Okay, let me switch on the motor. You see, the motor is switched on and you can see, so this is 1 HP motor. So it's supposed to show us 746 watts, but now it is showing us 759, 760 watts. It is drawing the current 3.54 amperes at 240 volts. Okay, so this and all you need to understand. You see, my dear friends, now at 240 volts, when this motor is drawing 3.5 amperes, so the multiplication of the voltage into current, it is showing us 756 watts, 1 HP motor, no? That's why. You see, this is the 1 HP motor. So, now what most interestingly you can understand from it, the fourth reading, the 0.08, that and all is watt hour, energy. Okay. So, that is nothing but power with time is going to be your kilowatt hour. So we can understand from this, suppose if I keep this motor on for minutes, hours, then we'll understand how many units of energy it is consuming. Likewise, I wanted to show you the energy power calculations, energy consumptions, all that for all my electrical appliances I use in my home, like rice cooker, AC machine, refrigerator, every other. So suppose say this motor, instead of 756 watts, if it has shown me more, like 850 or 900, whatever, then probably the bearings went wrong, so I can go for maintenance. So this is how we need to understand, whether the electrical appliances are working at rated power, rated energy and all, or otherwise they are working more or whatever. Then we can go for maintenance so that we can save energy. Okay? Saving energy is saving nation. Okay, my dear friends, now I am going to show you the voltage, current, power, energy and with respect to time. So I have switched on my cell phone's stopwatch. Okay, I am going to make it on now. Okay, you see now, I am going to power on the motor. So exactly at 2 minutes I switched off the motor so that you can see. You see 0.28, 0.29, 0.3 watt hour for 2 minutes. So now we need to understand, if this motor is on for 1 hour, what will be the energy consumed? So this is how we need to understand, if this motor is switched on for 1 hour, what will be the energy consumed? Or what is the liter per minute delivery of this motor and how many liters it is delivering? For suppose say for uplifting 1000 liters, what is the time it is taking and then what is the energy it is consuming? So this is how we need to understand the power efficiencies, all that of the motors, and this is how we can really understand everything about electrical appliances. Okay then. Okay, my dear students, now I am going to show how my energy meter can help me understand how much energy, electrical energy, I am going to consume to prepare my rice ready. I mean, this is an electrical cooker. So this is a Panasonic electric rice cooker. So we are using it for several more years now. Now I wanted to know, like what my mom has done. See, you can see already she kept rice and water and everything inside. Okay. And now I want to make sure, how much time it takes to prepare the rice ready. And now I am going to switch on, you see, I have switched on my energy meter. And now what it is showing me, you see, you all can see. So on my energy meter at 248 volts, it is drawing, this rice cooker is drawing around 2.1 amperes of current. So as it is purely resistive load, the power factor you can see maintained well at 1.00 and the frequency is 50, and now the watt says 513 watts. Okay, now what we can do, you see, I am going to set up like this. See, I am keep pressing this button for little time, and now you see I have cleared the energy. Now it is 00. From this situation, what we can do is, there is a button here. It is cooking now. So after the rice is ready in my rice cooker, once all the water will go up, like gets evaporated, and my rice is ready. At that time it automatically switches off. I mean, it will go from the cooking mode to keep warm mode. At the time when it goes from cooking to keep warm, at that time we will see the sound also. It makes a little sound like. At that time we will see here how much energy it consumed for preparing my today's lunch, the rice ready for my lunch. Okay, let's see that. Today we will understand that. So this is how, my dear friend, as I told you, at every electrical appliance in my home, I am going to I'm going to calculate all the energy consumptions. For otherwise, what's happening? We are simply paying the electricity bills, for whatever units we consume. But we never know to prepare 1 glass of rice to be cooked, how much energy is consumed. Likewise, now and then we will be calculating, all the energy consumptions of various electrical appliances. So now I am showing you all about electricity consumption of my rice cooker. My dear friends, now you see, after 15 minutes we can see 140 watt hour. Okay. So at this time our cooker is still cooking. So it might come anytime to keep warm mode. But at the same time, let me open the lid and see whether the rice is cooked or not. Wow! Rice is ready, man. Okay, it is cooked. But however, it is still saying it's cooking. So we need to understand, though it cooked well, but it is still saying it is still cooking. That means there might be little water content inside this. That's where still main cooker is on, main heating filament is on. So at any moment that might change to keep warm. That means low power consuming element will be connected. The high power consuming, the 500 watt filament will be switched off, and 20 watt filament will get connected. So here you see, now you still see that it is drawing 2 amperes and then the power is 517 watts. That means the main filament is still in connection. Okay, now you see what happened suddenly. Wow, so nice. While I am explaining, the current came down to 0.2 ampere. That's where 50 watt. That means the main heater got cut off and the keep warm heater is on. Let me go and check that. Oh, so nice. You see, my dear friends, yes, exactly. The main heater, the main cooking switched off to the changeover has taken from main cooking element to the keep warm. I mean from 500 watt to 50 watt. 10 times the power reduction. That means, but however, if you just continue using this rice cooker in keep warm mode also, it is consuming 50 watt, which is not small amount. So I wish you all will switch off the main power also, because as soon as the cooker is cooked, and why do we waste 50 watts of energy also just for the name of keep warm? Okay. So if it is 10-15 minutes, okay, but if it is long hours, like lot of people, they always will switch on this rice cooker and then they will come very late after, like even after 2-3 hours or sometimes 3-4 hours also. So 50 watt into that many hours are wastage of the power. just for keeping the rice little warm. Okay, that's not really good according to me. Okay, this is how my today's tinkered energy meter is making you understand a lot of things. I hope you enjoyed my today's tinkering. Okay, then I'll show you this kind of energy calculations and some other electrical appliances also. But here, what interestingly you understood, so with around 160 watt hour, that means not even 1/5 of the unit, because you all know that 1000 watts consumed in 1 hour is 1 unit. But now the watt hour is just 160, 157, 160. So roughly 200 watt hour. That means 1/5 of unit. So what you can understand, my dear friends, how efficiently this rice cooker cooking your rice every day for your lunch to prepare this much of rice. That's it. 1/5 of unit you are spending for it. So, and again in the evening another 1/5. So likewise, how many times 1 unit can help you preparing your rice cook? That and all you can calculate. Very nice. Very interestingly. So, power with time is the energy. Okay. So, understand that way. Okay then. Bye-bye. Hello. Good morning, my dear friends, my dear tinkers. On this Earth Day, 22nd April, my assistant is trying to prepare idli atta. So, I wanted to know how much energy is consumed to prepare this idli mix. So she prepared everything and she's supposed to switch on my ultra watt grinder. So we have reset the energy meter. You see the watt hour is 00. Now the present voltage in my home is 243 and current pulling is 0 because we have not switched on the watt grinder. And so V into I is 0, V is power is 0. So energy is 0. Power factor is also 0, but frequency is good, 50 cycles coming from outside line, utility line. Now my dear friends, I'm going to ask her to switch on the ultra watt grinder. Now she is switched on. See? She is putting all that stuff. Now we can see it is pulling, ultra watt grinder is pulling 1.132 amperes. Because of that, the power factor is very poor, 0.47, 0.46, something like that. So we need to improve the power factor also by doing something. But because of low power factor, the watts is also showing low. So this is how we need to work with this. The power factor is very low. Okay? So we have to improve the power factor. Anyway, at this point of time, to do this work, there is some work going on, my friends. Because of that work, it is consuming 124 watts. Now it is started. See, the time is also there. Okay. So we need to see after how long. So finally, the energy consumed, that and all we can see. Now it is 2.5 minutes. For 2.5 minutes, this is a situation, and now I think she is going to put some more also. Okay, so let's see. Put some more. Put some more. As she is putting more and more load in the ultra watt grinder, that's why from 124 watts to it went up to 133 watts. So another 10 more watts is more load because she kept more work for the ultra watt grinder. So work done, energy required, at what power, what is the voltage we have at home, how much current our electrical appliances are pulling, so that the power and the energy, all these things, my dear friends, you all need to understand. That's why I always ask you to take a course, Energy Literacy Drive, designed by my solar guru, Sri Chetan Singh Solanki, Professor Chetan Singh Solanki, professor at IIT Bombay, founder Energy Swaraj Foundation. He has taken a big oath. He is there in solar bus home and moving all across the country to sensitize all the people to understand going on renewable energy, stop using fossil fuels. So today 87% of the energy what we are consuming is coming from burning fossil fuels like coal, gas, oil, whatnot. So first of all, you first understand for what work, how much energy you are consuming from the regular utility line, fossil fuel based energy. Okay, then we will try to make use renewable energy to do all our work done. Okay, required works to be done. Now she is going to put more. Okay, she is going to put more. And then we will see the current, how much it is going up. In between it has come down, see 1.118. Now it's going to be more because she is putting more and more into that, and the machine will draw more current. The motor will draw more current. More the load, more the current pulling, more the power required, more the energy consumption. Okay. So, and she is going to leave it. This one, this ultra wet grinder, some more minutes, few more minutes, maybe another 20 minutes also. So she will test whether that has become softy so that she can mix idli rava and then prepare idli mix ready for tomorrow's breakfast. But we need to understand all these calculations. So earlier we have recorded the energy consumption from my regular rice cooker, electric rice cooker, and also we have done the same thing for our motor pump, water sump pump, and also we have done for the washing machine and all that. And then onwards we will show every electrical appliance how much electricity they are taking, they are consuming. Okay, now it is 6 minutes after she started the process. In 6 minutes you can see 11 watt hour, 12 watt hour. If that becomes 1000 watt hour, that's 1 kilowatt. So let's see how many units of the energy my wet grinder is consuming today for my required work done to prepare that. She kept some water also now to make the job easier. That's why the current went so little low also, because now it has become little soft, so it is not taking that much of current. Okay, anyway, we need to understand all this. Okay, so what we will do is, when she will call me again that I am going to finish it off, at that time I will come and show you again. Okay, till then observe, calculate, understand my video again and again. Bye bye. Hello my dear thinkers, after 20 minutes, you see, she is ready to take out. She is feeling it is prepared. Yes, is it prepared? Yeah, her idli paste is prepared. She pasted that idli dal, that udit dal. Okay. Now we want to see how much energy has taken. Okay. Now let us go to the meter. You see, my dear friends, after 20 minutes, see the voltage is 249, slightly went up. Earlier it is 246. Now it is drawing 1.143 amperes. Continuously keep on pulling. Now the power is 156 watts. loaded by this wet grinder. Whenever she is trying to stop, she's putting her hand inside to make, that's why the watts is going up. You see, sometimes she is doing something. So when he's trying to break the wet grinder with her hand for some manual hand, she is pressing the ball, that's why the power is going up here. When she is removing the hand, at that time it is 148 watts. Okay, anyway, whatever. Now so far the most interesting fact is 124 watt hour. Now if it becomes 1000 watt hour, that's nothing but 1 kilowatt hour. That's nothing but 1 unit of power consumption, right? But it is just 125 watts. That means you just imagine how much, what is the unit? It's not 1000 watts, it's just 125 watts. So, it is something like 0.125 units. So, 1 unit, if it is costing the electricity is 10 rupees, then you can feel here, as of now, I think it is going to be 1 rupee 26 paisa. So this is how we need to understand. But amount is not important, but energy consumption is more important. So I believe my ultra wet grinder is working efficiently. But however, the power factor, see, it is 0.25, which is not good. So we need to, because of the 0.2 power factor, the energy, the power itself is showing less. Why? Because P is equal to V into I cos pi, because it's a AC, alternating current. So the cos pi is 0.5, which is nothing but making the power value off. So we have to double the power, then we can double the watt hour. So it is not 130 watt hour, it is 260 watt hour. That means 300 watt hour. It's nothing but 1/3 unit. That means if the unit is costing 10 rupees, so to just prepare this idli mix ready, she spent around 0.3 units. That is nothing but 3 rupees she consumed for making this ready. So this is how you can understand the science, technology and the commercial things behind. Okay then, bye bye. Signing off, your science friend, your tinkering friend, Tinkering Srinivas from scientificstudents.com/tinkers-masters.html. Bye bye, take care, thank you.